We have prepared a tutorial video about the MySQL library used to store data in the Python programming language. In this video, we will install the MySQL program used to store data on our computer. We will connect the MySQL program with the Python project file. We will learn how to create database and table using Python programming language. Next, we will make examples of the insert, select, where, order by, delete, drop table, update, limit and join commands that are frequently used in the MySQL library. So let's start. Let's install the MySQL program first. We will install the MySQL program from this website. I will share the download link in the description of the video. Go to the download section on the website. We will use the free version of the MySQL program. Go to the MySQL Community Download section. Since Windows operating system is installed on the computer, I will use the MySQL program specially created for the Windows operating system. Download this file to your computer to install the MySQL program on our computer. If you have an Oracle account, you can complete the download using your subscription. If you do not have a membership, you can click this button to start the download process without being a member. The download was completed in a short time. Begin the installation. Select Custom as the setup type. To use the MySQL program, we will download two programs to our computer. Using these two programs, we will connect MySQL and Python project. First, select the MySQL Server program to be installed on your computer. You can make the selection process by clicking the green arrow button. Then, to use the MySQL library, select the MySQL Workbench program by pressing the green arrow button to install it on your computer. Press the Next button. Press the Next button again without making any operation in this section. Press the Execute button to start the installation process of the two programs we will use to synchronize and use the MySQL program with the Python project. The installation process will be completed in a short time depending on the speed of your computer. The installation process is complete. Press the Next button. Press the Execute button again to install the necessary files of the MySQL program on your computer. The installation process will be completed shortly. The installation process is complete. Click the Next button. This section contains information about the SQL repository we set up. Click the Next button without making any changes. We will set a password for secure access to the SQL database. For this, select the Use Strong Password option and click the Next button. Create a password. Using this password, we will connect to the MySQL database and synchronize it with the Python project. Check the usability of the password you have set by clicking the Check button. After setting the password, click the Next button. Specify a name for the MySQL database. Click the Next button. Click the Execute button to start the MySQL database setup. The installation was completed in a short time. Click the Finish button. The Workbench program is started automatically. Click this button to synchronize the database we have installed with the Workbench program. Enter the database name you created and click the OK button. We synchronize the database we created with the Workbench program. Click the button to enter the database. We set a password while setting up the database. Enter the password you set to access the database and click the OK button. We have successfully accessed the database. Create a schema. Specify a name for the schema. Press the Apply button. The code information of the schema you created is given. Press the Apply button. Press the Finish button and activate the diagram. Let's create a table in the schema. Press the Create Table button. Let's create a phone information table. Specify a name for the table. In this section, you can specify the table's titles and the types of title content. For example, let's assign an ID for the information we will assign to the table. Set the ID data type to integer. There are concepts such as primary key, not null, unique, auto-increment when creating a column. Using these concepts, we can determine the properties of the information we will create. Primary key in the relational database model, it is a particular selection of a minimal set of features that uniquely specifies a sequence in a relation. The value not null represents the obligation to enter data into the information. Unique ensures that all values in a column are different. You can create an auto-incrementing column using the auto-increment feature. Let's tick these options for ID information. Create a column for the phone brand. The data type is set to varchar. Check the Not Null tab for the data entry requirement to the column. Create a column for phone price information. The data type is set to varchar. Check the Not Null tab for the data entry requirement to the column. Press the Apply button. Table information is shown to us as a code. Press the Apply button. Press the Finish button and complete the table. Let's start sending data to the table by clicking the Select Rows button in the table. Submit 5 phone brands and prices in the table. Press the Apply button. The code information of the table we will create is shown to us. Press the Apply button. Press the Finish button and create the table. Notice that we are automatically incrementing the data of the ID column using the Auto Increment feature. Using MySQL codes, we can reach the information we want from the table. We can request specific information from the table using the where command. Click the Execute button in the Query section to run the code. As you can see, we can see any specific information we want with this method. Try another query and run the code. There are many table codes that we can use in the MySQL program. But in this tutorial, we will use the Python programming language instead of using the MySQL program. We will create a Python project and synchronize it with our MySQL project. We will perform the whole coding process in the Python code file. Click the Open Folder button to create the Python project. Create a project file. Create a Python code file to start coding in the project file. You can use a simple print command to test that the Python project is working. Run the project and check. The project ran without errors. In order to use MySQL features in the Python project and synchronize it with the Workbench program, we must transfer the MySQL library to the project file. Using this code, we can initiate the transfer process. The transfer process was completed in a short time. Restart the project file for the transferred MySQL files to run without errors. Transfer the MySQL and connector files to the project code file to test the transferred files. Run the project. The transfer process was successful because no error appeared on the terminal screen when the project was running. Let's start synchronizing the MySQL Workbench program with the Python project. We will use the MySQL and connector commands to start this process. We need a host information to connect to the project we set up in the MySQL program. Go to the Workbench program to access the host information. You can access MySQL project information by clicking the Session button in the Workbench program. The Session section contains the necessary information to establish the connection between the Python project and the Workbench project. Copy the host information. Go to the Python project file and sync the host information. We need the user information to establish the connection and access the database. Go to the Workbench program with the same method and transfer this information to the Python code file from the Session section. We set a password while creating the database in the Workbench program. We will use this password to synchronize the Python project with the database. Create a password variable and sync it with the password you set. Print the connect variable you created using the print command to the screen. Run the project. We have successfully established the connection between the database and the Python project, as the project runs without errors. Let's start the process of creating a database using Python codes. Previously, we created a database manually in the Workbench program instead of Python codes. After this stage, we will do all database operations using Python codes. Click the Drop Schema button and delete the previously manually created database. Go to the Python project to get started with database creation. Create another variable using the cursor method with the connect variable. Using the execute method, we can use MySQL codes in the Python script file. Use the name of the database you will create in the execute function together with the create database method. Run the project. Go to the Workbench program to see the database you created using Python code. Click the Refresh All button to see the changes made. The database you added has been added to the Workbench program. You can see all databases in the Workbench project in the Python code file using the show method. Create a for loop and print the database names on the console using the print command. Run the project. In the Workbench program, we can print the names of all databases on the console screen using this method. To directly access the database created using the Python script file, create a database variable within the connect function and synchronize it with the database name. Run the project. Now we have directly connected the Python project to the database created in the Workbench program. Let's create a table in the database we created using Python codes. To begin the table creation process, create a variable using the cursor function. Specify a table name and create a table using the createTable method in the execute function. Set the column information in the table as name and address. Edit the data types of name and address information to varchar. Start the project. Go to the Workbench program to check the table. Click the Refresh All button. We created a table in the database using a Python script file. Click the Select Rows button to see the table. Column information in the table is set as name and address. You can see the tables in the database using the Show Table method. Create a for loop and print the table names in the console. Table names in the database are printed on the console screen. We need to reduce the font size to better see the encodings we will do soon. To reduce the font size, go to the Settings section. Let's change the font size in the Settings section of the project. Let's create another table using the createTable method in the execute function. Add an ID column information for the new table. Set the ID column to primary key and auto-incrementing. Add name and address information to the columns of the table. Edit data types. Run the project. Go to the Workbench program to see the new table. Click the Refresh All button. The newly created table has been added to the database. We can see the table by clicking the Select Rows button. Let's add an ID column to the customer's table we created first. Set the ID column, primary key and auto-incrementing. We can use the alter table and add column method in the execute function for table column changes. Run the project. To test the change made, go to the Workbench program. Click the Select Rows button. The ID column has been added to the table. Let's start adding information to the table using Python codes. We can enlarge the font in the Settings section to see the code better. Create an SQL variable. We will transfer data to the customer's table using the insert into and values methods in the SQL variable. Create a variable to pass data. Synchronize random name and address information with variable. Synchronize the execute function with the two variables you created. Use the commit function to start the data transfer process. Create a print command to see the number of data saved in the table on the console screen. Run the project. We printed on the console screen that one data was added to the table using the print command. Go to the Workbench program to check the data. Check the table by clicking the Select Rows button. The data has been added to the table. Instead of sending just one data, you can send many data to the table in the database at the same time. Transfer 13 data with name and address information to the table. Use the execute many function instead of the execute function to transfer multiple data. Run the project. 13 data were transferred to the table. You can check the table by going to the Workbench program. Click the Execute button to run the code in the MySQL program. We can see 13 data that we transferred to the table using Python codes in the Workbench program. Let's send one more data to the table. Since we do not send more than one data, we will use the execute function. We can see the ID number of the transferred data on the console using the lastroid method. Run the project. Using the lastroid method, we printed on the console that the new recorded data is data number 15. To see the new data in the table, go to the Workbench program and press the Execute button. 15. The data has been added to the table. Let's start learning how to use the Select From command. We can see a specific information we want from the table by using the Select From command. Let's make a simple application. Using the Select From method, we can print all the data in the customer's table on the console screen. We can use the Fetch All command to access all the data in the table. Create a for loop to print all the data to the screen using the Print command. Run the project. All information in the customer's table is printed on the console screen. Instead of accessing all the information, let's show only the names of the data on the console screen. Run the project. Only the names of the data in the table are printed on the console screen. We can print only the address information of the data in the table on the console screen. Run the project. Only the address information of the data in the table was printed on the console screen. The table contains ID, name and address information. At the same time, we can only show the name and address information on the console screen. The name and address information were displayed on the console screen. Using the Fetch One method, we can access the first data in the table. We reached the data in the table using the Select From command. Let's start learning the where command used to query information. Create a SQL variable using the select and where commands. Use the SQL variable you created in the execute function. Use the Fetch All function to get all the information in the table in the database. Run the project. Data matching the address specified in the where command is printed to the console screen. Let's do another example using the where command. Let's print the data with the keyword way in the addresses in the table to the console screen. For this, use the like method with the keyword. All data with the keyword way in the address information is printed to the console. When query values are provided by the user, you must escape the values. This is to prevent SQL injections, a common web hacking technique to destroy or abuse your database. The MySQL connector module has methods for escaping query values. We can fix this problem using this method. Let's start learning the order by command, which is frequently used in database operations. First, let's print all the information in the table to the console using the select command. We can sort all the information in the table alphabetically by using the order by command. All information in the table is listed alphabetically. Using the desc command, we can sort all the information in the table in reverse alphabetical order. All information in the table is sorted in reverse alphabetical order. Let's start learning the delete command, which is often used to control databases. Delete the information in the table with the address you specified by using the delete and where commands together. Use the commit function to perform the deletion. Create a print command to show the deleted data count in the console. Run the project. Only one data was deleted from the table because there was one data matching the specified address information in the table. To better understand the deletion process, go to the Workbench program. The data with the specified address is in number 4. Click the Execute button and update the table. Information number 4 has been deleted from the table. Let's use a delete method to prevent SQL injections, a common web hacking technique to destroy or abuse your database. Use the S parameter in the SQL variable. Create a variable and synchronize address information. Use the SQL and ADR variables in the execute function. Run the project. It is printed on the console screen that an information has been deleted. To test the deleted information, go to the Workbench program. The information with the specified address is at number 10. We need to update the table to see it is deleted. To do this, press the Execute button. Information numbered 10 in the table has been deleted from the table. Let's start learning the drop table command. You can delete the table using the table name with the drop table command in the SQL variable. Run the project. To see the deleted table, go to the Workbench program. The table is not deleted because we haven't updated the table yet. Click the Execute button and update the table. We deleted the table using the drop table command. Let's quickly do the table creation process that we did at the beginning of the lesson. For this, create a table in the execute function. Submit the ID, name and address column information to the table. Set the data types of the column information. Run the project and go to the Workbench program. Click the Execute button to update the Workbench program. We recreated the table columns. Let's start the process of sending data to the table. Create a variable. Use the insert into and values methods to start the data transfer process to the table. Create a val variable. Synchronize 13 parameters with the variable, including name and address parameters. Use the execute many function instead of the execute function as we are sending more than one piece of information to the table. Send the two variables you created to this function. Use the commit function to perform the data submission. Create a print function to show the number of recorded data on the console. Run the project. 13 data were recorded in the table. Go to the Workbench program to check the saved data. Update the table by pressing the Execute button. The data has been successfully saved to the table. Let's start learning the Update Table command. You can change the address using the update and set commands in the SQL variable. Specify the information you want to change the address using the where command. Send the SQL variable to the execute function. Change the print command to see the number of records affected. Run the project. We can see on the console screen that a data in the table has been changed. Go to the Workbench program to check the change. After updating to the table, the Valley 345 address information will be changed to Canyon 123. Click the Execute button and update the table. Valley 345 address information changed to Canyon 123. We can do the data change in a more secure way. Instead of writing the address changes in the SQL variable, we can show it in another variable. Create another variable and send the parameters to revert the variable you changed. Send the two variables you created to the execute function. Run the project. We can see on the console screen that one data has been changed. Go to the Workbench program to see the change in the database. When we update the table, the data with Canyon 123 address information will be changed to Valley 345. Press the Execute button to update the table. The data with the address information Canyon 123 has been changed to Valley 345. Let's start learning the limit command. Increase the font size to see the codes better. First, use the select command to see all the information in the table in the console. Synchronize the fetchAll function with a variable to get all the information in the table. Create a for loop to print the information in the table to the console. Run the project. All the information in the table is printed on the console. Instead of seeing all the information in the console, we can see the first 5 data in the console. Use the limit parameter for this. Run the project. The first 5 data in the table are printed to the console. Change the limit parameter and run the project. The first 7 data is printed to the console screen. You can specify the data range using the offset command. Run the project and test it. In this video, we installed the MySQL program used to store data on our computer. We connected the MySQL program with the Python project file. We learned how to create database and table using Python programming language. Then we made examples about insert, select, where, order by, delete, drop table, update, limit and commands which are frequently used in MySQL library. If you have any questions, let me know in the comments. You can also support us by subscribing to the Turtle Code YouTube channel and other social media accounts.